Hello everyone, we're solving Leetcode today by the Anagram. Easy question, nothing too complicated about this question. One of the best questions to start with. So let's just jump right into solving this question. Given two strings s and t, return true if t is an anagram of s and false otherwise. Okay, so we have given two strings and we just need to check if t is an anagram of s. Okay, let's just understand what an anagram is. So according to Leetcode, anagram is a word or phrase formed by rearranging the letters of a different word or phrase using all original letters exactly once. Okay, perfect. So for an example, let's say if we have bat here, okay, as a word. So if you rearrange the letters of this word bat, not adding a letter or not subtracting a letter, we can get tab, right? Or we can get A, B, and T. So it doesn't have to make sense, but we just need to use the same letters as the word bat. Same letters are used to make bat, right? So so these two words are an anagram to bat. Perfect. Anagram of bat. Perfect. So why here rat and cat? You can see T here in rat and C. So always we need to compare the string T with S. So C is different here. If it would have been T, then for sure it would have been true. But right now it says false. Perfect. So we cannot add a word, we cannot subtract a word. It has to be the same. Um, okay, perfect. So we have a clue here. So as a beginner, what you should do first of all, first thing first, um, you can notice pretty early on that to have an anagram, you need to have the same length, right? Because you need to have the same count of letters. It cannot be more, it cannot be less. So we can always set up a check here. Okay, so we can just compare the lengths of the two. Let's just quickly get it here. So we're just comparing it, and let's save the length. If there's a difference in their lengths, then we just return false. Perfect. That's set up here. What else? What else? How do we get to know? Because here, as you can see in example number 2, rat and car, the length is same, but it says false. Why? Because here we have T, here we have C. So we need to find a way to essentially find out the different characters, the not matching characters. So what essentially should we do? Um, we can sort the array. We can sort the words here. So if we let's take bad as an example again, and if we sort bad, it would look like something like ABT, right? And if we have an anagram of bad, which is tab, and if we sort it, then it would be ABT, right? You see how the words, if we sort anagrams, we get the same word. And then we can just compare each letter with each letter with the next word, and we can figure it out if it is an anagram or not. Perfect. So it's a pretty easy solution. So we just need to have sort our word and compare each letter, each character by character, and that's it. So how do we do it? We first get them into a character array. Let's just say SS. Okay, and S dot to char array, and then we just sort it, right? So arrays dot sort, and then we just sort it, and then same goes for T, string T. So okay, TT, and then T, and then we just sort it. Perfect. And how do we compare it? So it's just a simple for loop. I hope you guys know how to have a for loop. So we just have the length um, less than the length of SS, which is our character array for string S. And yeah, that's it. And we just need to compare these two arrays now. So how do we do it? SS I, and if it's not equal to TT of I, oh, oops, and yeah, that's it. We return false. Perfect. Okay, so here it is. And what if it does not fall into this if block? Then we just return true, because if there was no difference, then we can safely say that it's an anagram. Perfect. Just so you have a proper view of the code. Um, Here's the code. So we are okay. Perfect. It should work now. Let me just test. Okay. Perfect. Yes, it's accepted, and let's quickly submit it. Okay, perfect. So it got submitted. Perfect. Okay, so here is the code. Okay, so time complexity of this code is n log n. Why? Because we're sorting their array. So it's going to be n log n. Right? It's nothing too great about this program, but your interviewer will definitely ask you to optimize it. And how would you do that? How can you optimize your solution? Okay, so um, optimizing it meaning, can we do it in constant time? Can we do it in constant time? Let's think about it. Um, we have anagram. We are first of all sorting it, and then we are comparing character by character. Right? What can we do more efficiently? So how about we just don't sort it, right? And we assume that T has all the same characters as S, which means, let's say, if, for an example, let's imagine um, there's a box in which you're dropping all the letters of string S. So you have A here, you drop it in a box. Okay. You have N, you drop it in a box. You have A, you drop in a box. Same goes for the entire letter. Okay. Next, you go to T and then you say, hey, you have N? Okay, let me find it out in the box. You find it out N. Perfect. And then you say, oh, you have A. And you find it out in the box, you find A. Perfect. By the end of it, by the end, which is by the end of, let's say you have reached on M, there should not be any other letters in that box, right? Because if there is a surplus, that means it's not an anagram. And if you think there's a deficit, if you couldn't find a single word, then it's definitely not an anagram. So this is quite a smart way to find if a string is an anagram. So what can we do? We can have an array count, okay? Since it could be 26 because all the letters are just 26 letters, right? At least in English. So we have 26. The size of the array is 26. Okay, we're going to we're going to quickly parse s. Okay, so we're going to move along. So we find a. Okay, so let's just quickly int I is equals to 0. I should be less than s dot length. And okay, perfect. So we have our for loop set up here. Now, what do? We can have our count array. So count array, and then we can essentially, so just like how we have arrays and there are Um, okay, so for an example, imagine this as an array with characters, and one represents that we have A there, right? On position 0, we have 1, meaning we have B on position 1. So, okay, let me just make you understand much better. So let's say this is 0 index, 0, 1, this is 2, this is 3, this is 4, right? So if we have A in our string S, then we put 1. If we have B, we put 1 there. If we have C, we put 1 there. If we have D, then we put 1 there. And so on and so forth. Let's say if we don't have A, okay, we don't have A, so it will be 0, just 0, nothing else. Perfect. So that's what we're going to do. So how are we going to do it? So string S dot char at I, okay, which means the first character, which is A, and if we subtract it by letter A, we will have a relative index of it, okay, meaning it will give us 0. So if we have 0 on position 0, we just increment, okay, and same goes for T. So now since we have dropped A, we're going to take out A, okay, so minus minus and S, and we're going to look in T, okay. If we have um let's say if we are right now our N, so okay, so on index 0 it will be -1, and once we reach here and we reach here on N, string S reaches on N, so on index, so this will be N minus A, and on that very index it will be 0 again. Why? Because here initially we got N and then we set up to -1, so it's like total sum is 0, right? We're just making total sum, making sure that total sum is 0. And once we do that, we just need to parse the array again. So we need to just parse count, okay, in 0 I less than count dot length, okay, and then I plus plus. So we're just parsing count and making sure if all the characters are 0 or not. So what we can do is just have int num here and carry. So we are using for each loop, okay, and num. So if num is not equal to 0, then we can just simply return false, right? Otherwise, we can return true. Perfect. All right, so that's the solution of it. Let's quickly check. Oh, it's a compiler. Okay, we missed a semicolon here. Perfect, it's accepted.